Now here's a much more complicated example, and I didn't want to draw this one out, so what I'm using is a printout from a page of the UML 2.4.1 standard. So I thought I'd just talk you through this. You may not be able to see the details of the diagram in the video. I'll put a copy on the web page. Several things to say about this. It's fairly similar to the other case. We're still talking about objects with their lifelines, and we're still talking about synchronous messages with the filled in arrowheads like that. But some things are different. We've got a box around the whole diagram with this pentagonal corner, and it's labelled SD example. SD stands for sequence diagram, telling us this is a fragment of sequence diagram. And this is useful because it lets you build up sequence diagrams compositionally, which is especially helpful when you go beyond wanting to represent individual scenarios, examples of behaviour, and towards wanting to represent all the different ways in which the objects could interact. And this diagram is on the way to that. The whole thing is set off by a message from outside called opti. This is an invocation of an operation opti of this object called ob1 of class C1. So class C1 has to define an opti operation somehow. But then things get complicated. We have this other sequence diagram fragment in here, and this one has alt in its corner, which stands for alternative. This is letting us represent two different things that might happen, two different scenarios on one diagram, one of which applies if some variable x is greater than 0, and the other one which applies if it's not. Now, because it's not defined anywhere else, it's probably the case that x is an instance variable of object 1 of C1. There are other possibilities, let's assume it's that. So we're going to say if x is greater than 0, then what happens is, first of all, this object of class C1 creates an object of class C2. Notice that the object rectangle here is being shown further down to indicate that it didn't exist earlier in time than this. It's just being created. The next thing that happens is that we send this message foo to the newly created object, and it, because it implements message operation foo somehow, is going to send do it to a fourth object, ob4, over here, and then that's going to reply. This object then sends its reply to the original message foo, and then it gets destroyed. Maybe it's being garbage collected, or more likely, since it's shown explicitly with a cross like this, its owner, object 1, is actually going to delete it. Maybe we're in a language like C++ or something like that, where you do explicit memory management. And then we're done. Alternatively, if x was less than or equal to 0, we're going to send a different message. We're going to send bar to object C3, which is going to send do it, which is going to reply, which is going to reply, and there's no need for any of this object creation. And finally, in either case, object 1 of class C1 is ready to return to the original sender, to the environment, we say, on the outside of this original sequence diagram fragment. What else should I say? Oh yeah, if you look at it in detail, you'll see some really weird syntax for arguments and for returns. Basically, I would say don't worry about that. What people do typically is they put arguments in the usual way inside the messages, and you'll often see people put return values on the return arrows in practice. That's what people often do. If you really want the details, you can look in the UML standard. That's it for that.